Hi everyone, my name is Stephen Simon and welcome back to C Sharp Corner live show. In this episode of C Sharp Corner MVP show, we have joining Zeeshan Ahmed all the way from Turkey. He's actually from Pakistan and he's been a C Sharp Corner MVP from last 4 to 5 years. But you can see my background has changed and I'm not in my room now. Just the way C Sharp Corner is committed to ensure that we provide the quality community content from past 2 decades. So we are committed with the live shows. It doesn't matter if we have a power backup or if we are not at the right place. We'll make sure that our live content reaches you at the right time. Having said that, let me bring upon the guest for today, and that is Zeeshan. Hi, Zeeshan, how are you?
I'm doing good. Thank you for having me.
Great, Zeeshan. So, Zeeshan, it's our second episode of C Sharp Corner MVP show, and we are doing this for the first time live. And go ahead and tell who you are, what you do, and how did you actually start your MVP journey?
Yeah, I mean, I remember it's been like almost a decade now that I've been in this industry, writing articles, providing solutions to online members, especially for C Sharp Corner. With C Sharp Corner, I've been for like 5 years. I joined back in 2015, and I've been an MVP since. So, I mean, it's been a great journey working with the experts on C Sharp Corner community, on GitHub, open source projects. So I look forward to sharing my learning for serverless today with the audience.
That's good. I think serverless is one of the very hot topic these days. It helps both the early age startups and the enterprise to manage all these services on the cloud. Why don't you go ahead, Zishan, and let's get started with the show. You can share your screen and then you're good to go.
Cool. And before I start, it would be a request to our audience to always ask questions whenever you have them, and we'll get back to you.
That's perfect. So if you are watching us on Facebook, Twitter, YouTube, and Twitch, you can just write your comments in below, and Zishan, our C Sharp Corner MVP, will answer all your questions. So your screen is there, and it's all your show now, Zishan.
Thank you. Thank you, Simon. Okay, so although Simon has already given you a one-liner for what C Sharp Corner is, but there's always more to the story. So we always encourage our readers. I always encourage my audience in the events that I have to visit C Sharp Corner, join it. Maybe you'll be the next MVP. Who knows? My introduction is that I'm a senior software engineer. I've been an MVP with C Sharp Corner since 2015. I have been doing a lot of offline workshops. I have contributed to several open source projects online. Most of my contributions are on GitHub, GitLab. So the topic that I'm going to be discussing today is serverless. Serverless is definitely an interesting topic, like Simon has mentioned. Most of the people think about serverless and they think that serverless is all about forgetting about the operational side of your applications. So that is what I will be talking about in this short talk, and I will be showing you how serverless is more than just the no ops for your applications. What people think is that and this is definitely a common practice of building your cloud native applications, is that you break down most of your applications into microservices. You develop them separately, you publish them separately, and you monitor or provision them separately. That is what serverless does as well. So how it differs from no ops or no operations is that I believe the no ops part for the serverless is more of a marketing term when it comes to like your solutions. So if you host your solutions on, say, Microsoft Azure, they tell you that you don't have to provision your serverless. That is not true, because at the end you still are going to be publishing your serverless. You're still going to be looking for the logs, and you will have to some in some way provision when something happens. The difference that comes in no ops and serverless is that you can scale as much as you can, so there is no limitation on the infrastructure that you get. And that is what I will show you in the demonstration, and a bunch of different areas that serverless is covering uh, with the cloud infrastructure, such as for Kubernetes, for database systems, etc. Another major benefit that one gets with serverless is that serverless offers cloud native integrations. Most of these integrations are first class products on the cloud platform. For example, if you're using Microsoft Azure, you will get cloud native integration for app service, Azure Cosmos DB. Same applies to Alibaba Cloud, AWS, and Google Cloud Platform. So these are the benefits that you get. But at the end, it all boils down to one single concept, which covers the entire serverless domain for your applications. And that is that serverless provides you with on-demand resources. So what that means is that mostly people think about cloud as a pay-as-you-go solution. So you host your service, and as much as you need it or as much as you consume it, you pay for it. But with serverless, what happens is that if you are not using the application, you're not paying for that. Think of it as an Azure app service. When your app service is running, you are being charged for that. There are bills for that. But when you stop the service, most of the resources are still there. For example, the source code is there, and a bunch of other services such as the Azure App Service Plan. It is always on the cloud platform. So what you do is you either remove that and redeploy the service when you require it, or you keep on paying for that when you are not using it. So what serverless does is that it automatically removes the services such as the resources required for your application to run, and automatically provisions and deploys those resources when they are required by your applications as well. So this on-demand capability of serverless gives it a really cloud native feeling and a cloud native experience to the developers as well as uh, let's say to the stakeholders. So they know that if they are using the cloud platform for say 5 minutes per day, they are only paying for those 5 minutes. And now comes the no ops part, because you do not require to deploy the applications again, because that is actually the part of the platform. Most of the popular frameworks that most of the audience will know are, say, Alibaba Cloud Function Compute, Azure Functions, AWS Lambdas, or Google Cloud Functions. Now Alibaba Cloud is basically uh, a new kid on the block, to say, but it provides uh, a really global scale uh, serverless platform, and you can use this platform to build any sort of application. Most of the frameworks that it supports are Node.js, Java, Python. So you can build your own applications on top of it, or you can break down your existing microservices applications and deploy them as services on Alibaba Cloud, and then monitor them as you go. Same applies to Azure Functions. With Azure Functions, what happens is that Azure Functions provides first-class integration support and connectors for most of the Azure Marketplace solutions, such as Azure Cosmos DB, App Service, Event Grid, Event Hub, and so on and so forth. AWS Lambda. Now, when people talk about the serverless technology, AWS Lambda is the first name that comes to their mind. Primarily, the reason being that AWS was the first one to offer such a concept of going serverless, where you only write one function, one specific task that needs to be performed whenever something happens. So that concept grew up and became the serverless. And today we have a lot of serverless offerings that originated from that concept of having one specific operation performed when something happens inside the infrastructure or outside the infrastructure, depending upon how you connect it. Same goes to Google Cloud Functions. Now many people don't use Google Cloud Functions. The reason being, the Google Cloud Platform is more of a consumer-facing cloud. It's not much of an enterprise targeting or enterprise facing. But Google Cloud Functions provides the support for most of the first class mobile solutions, such as Firebase. So Firebase uses all the power provided by Google Cloud Functions. And then Google also provides support for Knative, which is a serverless platform for Kubernetes, which I will discuss in the last part of this presentation. Now, before we dive into a quick demonstration, let us take a quick overview of what serverless runtime actually looks like. We have discussed that serverless provides on-demand support for resources that can be compute resources, or they can be other services. So what happens when a serverless application runs is that when there is an event inside your cloud or outside the cloud in a hybrid environment, your serverless application gets triggered. And as soon as it is triggered, all the dependencies, all the resources such as the cloud, such as the compute, RAM, or memory resources are allocated for that particular instance. You configure all of these services. So you configure how much RAM will your process require. You configure how much CPU are you willing to pay for one execution of the process, or how much will it require to efficiently process. And all of that is done for every event that happens inside your infrastructure. Once all of the resources have been allocated, then your process starts. The process can be an HTTP handler. The process can be a handler for, let's say, log, uh, or the process can be, let's say, for a database. Whenever a new record is inserted into the database, you can check if the data is valid, or say if the data should be inserted or not. Once at the start point, now your process is running, uh, and it executes for as long as it requires. Normally, a serverless runtime takes like one second to say 5 seconds or 20 seconds, and then it can raise notifications in other areas of your cloud. So this is the benefit that one gets when working with serverless, in that each serverless can be triggered by other serverless. And so when you are finishing up with your process, you can end up triggering another serverless. So for example, if there is a transaction that is being made on your cart or checkout phase of your e-commerce website, you can you can trigger your Lambda, and that Lambda can end up triggering another Lambda, which might be responsible for the payment or other parts. So this creates a very asynchronous microservice that you have, where most of your components are isolated from other components, and your services can run independent of each other. But they can execute and start running as soon as they have some events. And most of this is provisioned by your cloud runtime. While this architecture has some benefits in terms of, let's say, you don't have to provision anything, and if, like, for example, you have a sale going on Christmas Eve or Black Friday, you can see that, your customers might be sending requests in billions, because millions is only a funny number during a Christmas Eve. So what you do is, you create a serverless environment, and you allow your cloud platform to provision all the resources that are needed for that runtime. And each of the requests is isolated. So if one request fails, your server or the entire process does not crash. It's that one specific request. There is one downside, however, that I personally feel everybody should know, is that if you see on the left side, all the way from the triggered part to the start part, that is now a dependency. That is basically a debt that you have to pay for each of the resources, for each of the event that happens inside your system. So let's say you are using .NET Core, and you are building up your Lambda environment, but your Lambda requires a couple of dependencies, such as you're using MongoDB, so you require MongoDB driver. You are using JSON converters, so you're using JSON.NET, and a couple of other helpful libraries inside your Lambda. So what happens is that Lambda runtime will need to load up all of those dependencies and create uh, uh, an isolated instance for that request to be handled. Now, this happens for all of the requests. So if you have like a million requests, this dependency load will happen a million times. So in most of the times, this takes up a lot of cost, and adds up a huge bill in your invoice. So this is a primary problem that I see with the serverless runtime. And most of the clouds also require a minimum payment. So for example, if you're serverless, if you do not have those dependencies, so you plan to remove all these dependencies, and you say, okay, so I just have a function, I will make sure that the function executes as soon as the event is raised, and as soon as the resources have been provisioned. And so you make sure that everything is, like, it's sent down to the metal of the process. You can do that. But then cloud platform comes in and they say, okay, this is the minimum. This is the minimum execution time that you can have. So, for example, if you write a function that takes 20 milliseconds or 30 milliseconds, but the cloud platform will be charging you for say 100 milliseconds, and and same for the memory requirements and the CPU requirements and all. So in a way, this takes us away from the pay-as-you-go model, where as soon as you spin up the resources, you are paying from that point onward all the way until you release those resources. So that is one model. The serverless model says you don't have to provision the resources, but whenever we provision your resources, we will be charging you for at least a specific amount of time. And after that, if you continue executing, we will charge you per second. Otherwise, we can simply remove your resources. So that is one problem that I personally see with the serverless runtime, and so we need to provision them. I'm working with a client, and we are basically digitizing their entire infrastructure. So what we do is in a couple of lambdas, because I have designed and developed their entire infrastructure as a serverless model. So we're using AWS for that. What happens is that most of the times there's each serverless instance takes say 1 second, which is okay. So now we don't need to provision anything. We don't need to have an EC2 instance or another beanstalk running all the time, because we only need to process it once every hour. So what we do is we run those instances. But sometimes what happens is that an instance only requires 15 milliseconds to execute. The complete runtime for a process is 15 milliseconds. But the client is being charged for over 100 milliseconds at least. And in most cases, it takes like, let's say, 30 seconds to process a complete document that they have in their own format. So these are a few of the constraints that one needs to look into before actually diving into the serverless, just because it's a buzzword. So now I'll go ahead and I will discuss one quick sample that I want to show, uh, and I will talk about all the areas that I have discussed on this slide, and then later on I will talk about what or how cloud giants are using serverless in their environments, and I will discuss like why serverless is beyond just a simple HTTP sample, or how serverless is beyond just like, let's say, an manager for your event grid, or let's say your IoT devices. So I will be using Alibaba Cloud. The overall method to create a serverless application, or to host a serverless application, or to execute a serverless application is similar. The only thing that you need to know is that a serverless runs whenever there is an event. Now, an event can be anything. It can be a change inside your say the state of the application, a change inside your database, or it can be an external event such as an HTTP request. So if you see over here, there are a couple of templates provided. We have video auditing, audio processing service, which will definitely be with the media encoders on Alibaba Cloud. If you're not aware with, or if you're not familiar with Alibaba Cloud, one thing that you can do is definitely you can go and create a free account with Alibaba Cloud. If not, you can use the same concepts on your favorite cloud, such as Microsoft Azure, AWS, Google Cloud Platform, or other online services such as Firebase. They all work. They all work the same. The code is same. You just have to read the input and provide an output. So if I go over here, Alibaba Cloud basically provides us with the concept of a service, and then we create different functions. Now, the concept of a service is similar to what we have as a microservice. We create a single microservice, which can be, say, a people catalog, or a cart, or a payment gateway. And inside each of the service, we create different functions. Now, these functions each control or manage, yeah, manage would be a better word. So they all manage one aspect of that microservice. So, for example, if we are building an HTTP based service, uh, we can have a service, and inside that service, we will have some managers for get, some for post, some for put. Now, I have had some arguments over the past with a couple of my colleagues, and they said that there is no point in creating different uh, or managing different HTTP methods in different functions. But I think most of the times your services do not have a balanced flow of the request. So, for example, if you have say a shopping cart, you will only be sending a post request like to add an item to that cart, say every 5 minutes. But you might be sending a get request to check how many items you have in the cart every 10 seconds or 20 seconds, right? So now the load is no longer balanced between those different endpoints because the get and post endpoints are two different entities. So you need to see, okay, so which of the endpoint is causing some problems, causing the delays, or are taking more resources, or which of these, or say when you are about to scale your resources. So you need to see which of these endpoints require some additional scaling or say additional compute resources to function properly. Uh, that may be a marketing term because now you want to discuss, okay, so these are the SLAs that I'm providing to my customers. So how can I make sure that my SLAs on the get request are not being eaten up by the SLAs on post request and so on. So now you can separate out these different components into different functions. So that is what I always recommend to everybody that talks to me about serverless. That if you are going to serverless, just think about writing everything separately. If you have to apply a single if condition, write it as a separate function. So for example, if you are processing a new file upload, you can easily check, okay, so if the file is a PNG, process it with this lambda. Okay, so if the file is a PDF, process it with this lambda or this serverless or so on. So that gives you a very brief overview of how your customers are using your serverless, which of the serverless is causing problems, or say which of the serverless are crashing. So then you can have your own team work on those serverless and improve the overall environment, right? So if you are using a simple if condition and you are ingesting all the files inside that single serverless, now you have to think, okay, so where exactly is the code breaking? I hope you understand the point that I'm trying to make over here. So that is what I recommend to everybody. So if I go over here, this is just a single function. What it does is it simply just says hello. It's just a simple hello world function. The interesting point is not whether it says hello world or not, because you can find that in all of the videos online. The point that I will be making over here is something more than that. If we go over here and invoke this function, this is basically a simple function. So now you see, if you see over here, uh, I'm not sure if you can see properly. Let me just magnify this a bit. I hope you can see it now. So if you see, what happened is that when your serverless was executed, so when I invoked a request, what happened was it logged that fc invoke start. So this was the request that started. Then it loaded the code from the code that I had provided it. It had stored it inside encrypted at rest for privacy and compliance. And then it went ahead and processed, it executed my code. So there are like four steps. First, the serverless gets a trigger. Then the serverless loads the resources. It provisions the compute resources on the cloud as well. Then it executes my code. Then finally it ends. Now the interesting part is you can see that for this hello world, our code only executed for 51 milliseconds, but the build duration was 100 milliseconds. So memory size we used was only 16 MB, but since we have already configured it to be 512 MB, so it charged us for 512 MB. We can configure the memory size, but we are unable to configure the build duration because it's always uh, it's a simple condition that it's always more than what your average duration is. So if you are using, let's say, 102 milliseconds, maybe they will charge you for 110 milliseconds or more than that. So that is what I wanted to show with this approach. Like, okay, so this is how serverless works. Now, as I mentioned, the serverless is no longer about a simple hello world function or your microservices going separately or like, oh, how can I put it? Like, for example, it's no longer that you're just breaking down your microservices further down into atomic levels, which become a function. Serverless uh, is now being used to create the entire infrastructures. So let's say you are using Kubernetes for your application. Okay, so I'll give it just a minute. I will just give a nice this touch so that the readers know that I'm not talking about the code anymore. So what happens is that when we are using Kubernetes, for example. So what happens on Kubernetes is that you create your containers and you say, okay, so my container will require 200 MBs of RAM each container. So you orchestrate it, and as the need grows, your Kubernetes orchestrator will automatically create new pods, create new instances inside the nodes, and automatically load balance all the traffic between different endpoints. So what happens is that now your application itself is scalable. It's elastic in nature, and it can take all the traffic that is incoming. But what happens is that your Kubernetes, the infrastructure is not at all scalable. So, for example, if you have three nodes, so let's say your Kubernetes architect came up and he suggested that, okay, so we can have one master node and a couple of worker nodes, say five of them, each one having this amount of RAM, this amount of CPUs, and so on. So that works just fine. But what happens when you hit that limit? Now you cannot change it, because provisioning new nodes, adding new nodes, removing nodes when they are no longer needed is also not feasible. So what happens is that most of these cloud platform providers, they offer serverless offerings for infrastructure. What happens is that now you only define, okay, so at the end of the day, I want this infrastructure to be hosted on the platform. And I don't care how you host it, how many resources you require, and how you do that. So what the orchestrator of the infrastructure does is that it provisions all the resources, creates nodes for you, adds them as they are needed, and removes them. So entire infrastructure becomes scalable. Recently, I was also studying a couple of weeks ago that Azure Cosmos DB, for example, it has gone serverless. What happened previously was that uh, you can provision, okay, so this is the minimum, these are the minimum resources that are required from a database engine, and these are the maximum resources that are required from a database engine. What happened was that you cannot go from the minimum. So minimum was, I think, the 10% of the maximum. So if you have like 10 hours use as minimum, you will have to have like 100 hours use as the maximum. But at the time when the application is not being used, especially in the development or testing environments, you are still being charged for those 10 hours use. Now, what happens with the serverless deployment option is that you're not charged for any of that. So as soon as the request comes in, so Cosmos DB will check will actually go ahead, process your request, provide you with the response based on its single millisecond read and the same SLAs that it provides. And when your instance is no longer being used, it will remove it. So that is where serverless is going nowadays, and I encourage the audience and the viewers to go ahead and try out these serverless offerings for specifically for Kubernetes, for Azure Cosmos DB, and build a new stuff. Recently, I was working on one of the projects which required a serverless platform for machine learning. So we have Kubeflow for that, and a bunch of other offerings which different domain experts can use and build their own solutions on top of. Yeah, Simon. So I think this will be over to you now.
That's great, Zishan. I think all right.
I think I did not bore
Perfect. So I
anyone.
think, Zishan, that was a really good session that you gave. I mean, you started with what is serverless, when it is important, what are the limitations. What I people would really love about this session is that you're bringing your years of experience and the projects that you're working with the clients you're taking those feedbacks and you have shared in this session. One question for anyone who's trying to move into this serverless technology, taking a feedback from you, what was the first services that it choose? I mean, you did talk about Azure, you did talk about services on AWS and Alibaba too. Which was your first cloud service that you chose, and what were the challenges that you had to face when working it for the first time?
My first serverless framework was Azure Functions. To be honest, I personally love Azure because of its simplicity. It is actually a lot simpler to build solutions on Microsoft Azure than it is to build solution on any other cloud. I believe, and I can prove that. I have been proving that to my colleagues, to my audience, and I think I can still prove it. So that is why I used Azure Functions. The challenges that I had were actually thinking about serverless things in serverless fashion because it's difficult. So when we were previously building monolith applications with the ASP.NET, when microservices came, like everybody was a bit puzzled, like, okay, so how does this thing work? It's a lot simple. And same was the concept when serverless came out. So like nobody knew like how, like I mentioned, like most of the people still think that serverless is just about like building a Node.js application and provisioning different functions. That is not all about serverless. The serverless is more than that. Serverless is more about the on-demand concept. So when you move ahead from the pay as you go all the way to on demand, so you can like have one of your pay as you go subscription. That is fine. You can host your applications on the cloud. But then there comes a time when you require more than just the serverless, more than just the pay as you go model. So at that time you can incorporate the serverless. So serverless is more like your control alt delete. Like they are the goons that come to solve your hardcore cloud native problems. So they're there to help you out.
That's great, Zishan. I think when you talk about the different challenges that you face, Zishan, so what were the different resources that you did refer when you were facing these challenges? I mean, talking with the team leads and manager and the leadership role is fine, but as a developer, what were some of the resources that you choose to learn this serverless and then come up with those challenges?
Mhm. Yeah, when it comes to Azure, I always refer to the Microsoft documentation. Documentation is open source. If you are an expert and you feel like the documentation is missing something, you can please contribute. Other than that, yeah, I've always referred to and used the Microsoft documentation only. They are the best resources out there, especially for the Azure. And you can also learn different cloud design practices and design patterns on Microsoft documentation, and that applies to other cloud platforms as well, so AWS and other. I've learned a lot of concept from those documentation, and I've applied that over to Alibaba Cloud, AWS, and Google Cloud Platform, and it's always worked.
Yeah, exactly. And also for people who may know that Zishan, the C Sharp Corner MVP, so he keeps on writing different articles, blogs, and video contents, not just on C Sharp Corner, but in the entire this community ecosystem. All right. So yeah, I'm back. Okay, there was just a little glitch. So, Zishan, so having said that, I think this is one of the best sessions that we had. It's almost like 30 minutes. We reached somewhere a very good audience. A couple of feedbacks and a quick tips that you would like to give to the audience that who have watched from last 35 minutes. A quick pro tip whenever if someone is moving into serverless and when they're deploying it. A pro tip from your end, and then we'll wrap the session.
Yeah, when it comes to serverless, I would recommend that instead of reading articles, you write your own article. So I think that'll be a one-liner from my side. Build something, share it on GitHub. Remember to do
I mean,
that,
you have been a true community
and
leader.
you can
Yeah.
definitely hit me up on Twitter when you write your own server.
Yeah, exactly. Zishan is very active on this social media platform, Facebook, Twitter, LinkedIn, right? So just ping Zishan anytime. You can visit csharpcorner.com. Just type Zishan over there. He's one of our top contributors. He has been MVP from last 3, 4, 5 years, and people always look at him. So Zishan, thank you so much for your time. You have been a valuable asset, not just to C Sharp Corner community, but to the entire developers community across the globe. We are very glad to have you in our community, and just thank you for your time. We look forward to seeing you on our next show.
Yeah,
So see you
thank you for
soon.
having
Take
me.
care, and thank you everyone who has watched. We'll see you in the next episode of C Sharp